Hello everyone. Let us now discuss count, prefix and suffix pairs 1. So, in the question we are given with, we need to find whether a word is prefix and suffix of another word. So, we are given with some words in an array. So, we need to consider whether the jth word is having prefix and suffix of either. So stick on. Here you got I. Now we need to traverse through this with J, and we need to consider whether this word is having the prefix and suffix as I. So let us take an example. Here we are given with words is equal to A, B, A. So let us take those words. Now we are given with these words. Let us consider this as I. This as I. Now, as I said, we need to consider the next elements, next words. So let us consider this word is having prefix A. This is having suffix A. So our count will be 1 initial. So from 0 to 1. And then let us see here. We have A as prefix and A as suffix. So increment by 1. And then here you got A as prefix and another A as suffix. So the count will be 3. So the count till now is 3. So now let us take this ABA. Now ABA is a prefix and also a suffix of this word. So let us increment the count 4, and if you take this word after this, if you take this word now till here the words uh, the count is 4. Now if you take this ABA and AA, this ABA is greater than the size of AA. So we do not consider this. The first thing is the size of I should be less than the size of words of J. So the size the size should be I should be less than J. Words of I size should be less than words of J. Now, there will be a brute force code. So, let us go through the brute force where we will be writing a Boolean function. Initially, we'll initialize count. If you need the approach which is used by tree, you can skip this part. Now, for int I is equal to 0, I is less than words dot size I plus plus 4 int j is equal to, sorry, as we increment after I, we are taking the uh, after I elements. Now j is less than words dot size j plus plus. If I, sorry, 1 minute. No, if is prefix and suffix words of I, words of j. So if so, we'll increment our count and we'll be returning our count here. But let me write this boolean function. Bool is prefix and suffix string 1 comma string 2. So if 1 dot size is greater than 2 dot size, as I said here, return false. As I said here, I should be less than the size of j. But here if it is greater, we need to return false. Now, if we need to check whether the suffix and prefix are equal. Now, substring of at 0 comma size of 1 is not is equal to 1, or sorry, 2 dot substring at size 2 dot size at the index, to get the index 2 dot size minus 1 dot size comma 1 dot size is not is equal to 1, then we will return false. If not, if these two conditions are not satisfied, then we'll return true. But if you need to know why this satisfies, 1 minute, 1 dot size substring, so 2 dot substring, yeah, 2 dot substring 0 comma 1 dot size is not is equal to 1, or 2 dot size max. Okay, so but if you want to know, here you got ABA, let me write it, ABA. As I said, 2 dot size minus 1 dot size. Here 2 dot size minus 1 dot size. That means here the size initially is 3. Here it is 3. Now 1 dot size is minus 1. So at this index 3 minus 1 it is 2, and here it is 0, here it is 1, and here it is 2. So at this index you will get the substring. So that's why I wrote 1 sorry 2 dot size minus 1 dot size, so to get to the index where you get the substring 1. Now let me go through using this tree. Now let me write that initially. Let us take one example where you get, wait a second, where you get A, B, C, D, A, B. Now, what this drive will be doing is it will initialize A, B, C, D, A, B. So, this is how the try or tree, I don't know how to pronounce it, tree is initialized. Now, here you can easily check whether it is a prefix or whether it is a suffix. Now, this is the prefix tree. But wait, how can we know whether it is a suffix? Let me take in the reverse order. Let me come in the reverse order. So, B, A, D, C, B, A, B, A, D, C, B, A. This is the reversed uh, tree. So this is used for calculate taking whether it is containing a prefix, and this is used for suffix. Now the thing is, you got one word like, let me say, A, B, and the another word which is not a prefix and also a suffix, it is like CD. Now the thing is, how can we get this AB and CD? The thing is, you got this AB. First thing, you got this AB. In prefix tree, you will search from the root A and then B. So, and in the suffix, you will reverse this. So, After reversing this word, you will get BA. Now, you will search this BA and you will get true for both the prefix and suffix. Then it is true. AB is true and you will increment our count. So, how can you do this tree or anything? How can you do that? So, I have wrote something here. The first thing is how this tree is initialized. Now, wait a second. You got this A, right? You got this A. But there are many chances this A can have only B, or this A can have B, C, and then it can have D or E. But wait, how many characters it can have? 26 alphabets are there, so it can have 26. So a node can have 26 characters, so we write a boolean function contains. So that means whether B is a children or A contains B, this will return true if we have that character as child for that node. And the second thing while initializing this tree is how you can insert this C for this node A. So we will write another function insert C comma node. This will insert a new node for character C. So now how you can get the next character for a node? So for that we will be writing a function next C where we get the next node for a character C. So wait here. Now the second thing, important thing is how you can search for prefix and for suffix. As I said, for prefix you will be going through the tree, and for suffix you will reverse the word, reverse the given word, and then you will search through the tree, the suffix string, and here as I wrote suffix string and for prefix string. Now insert function to insert a word. To search for prefix and insert a word, you will be using two functions, that is insert function and the search function. So in the insert function, to insert a word, the whole word from A, B and so on. So to insert a word for each character, check if already exists from the current node, and if not, we will be creating a new node. That means let us take this A and let us take A B. Now you got this A. After you get to this B, let me write that hypothetically you got C and you got like D, and but you didn't have a B. So what this will do is, if you have AB, if you have AB and if you have a C here, and for uh, this thing it will get B and then a C here. So let us take two words where it is having like A, B, C and then A, B, D. So after initializing this, when it gets to ABD in tree, A and then checks B, and then as it is already having, it will not create another node B. So this is why we are checking it whether it is already existing or not. Now it gets to B and then there is no D here. So there is no D here. So it will initialize after B. It will insert a new node D. So this is how this tree will work. After inserting all characters into the tree until the whole word is inserted. Now this is how you insert a word into this tree. Now how you can search for this prefix and also the suffix. So traverse nodes from top, and if there is a link, there is no link. In this example, Let us initialize this. Where it gone? Oh, here. Let us search. So here you got this AB. Wait a second. You got this AB. And another thing, let me write two examples. The first one is AB and the second one is CD. Now, this is one word which we need to search as prefix and also the suffix, and this is another word which we need to search. Now, AB. So you will be traversing from A. Yes, you got this. And you will be traversing to the next. And here you got B. So yes, it is having a prefix. Now, as I said, we will be reversing this word and you get B, A. Now, let us search. The first node is B. Okay, B and then A. So yes, B, A. So it is true and we will be incrementing our counter. Now, you got this C, D. Now, if you search for C, it is not there. It is not a C. So, we will return false here. We will return false here. So, this is how you will be checking the links. The links are nothing but, as I said, the contains function. You will get to know what is how this code works when I write this code. Now, traversing the nodes from top, if the character link does not exist, then we will be returning false. Else, we will be returning true if traversal is completed successfully. Now, let us let us write these codes. First, first you will be getting links where we'll be having 26 characters, and now we will be writing if a function contains character C. Now we'll be returning links of C minus A, whether the character is present or not. Now, after that, void put is for inserting a character C into a node. Now, links of C minus A is equal to node, and then node next, the next character of a node of a character is given by this function return links of C minus A, and we'll be writing the tree class tree. So here node root is equal to new node. Here we will be initializing the root node initially, and to insert string word. So to insert a word, you will be getting root. So node is equal to root. So then for character C word, if node contains 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 if it contains, you will be skipping. So if the node does not contain, you will be inserting the character. So new node. So you will be creating a new node. Then node is equal to node next of C. Then we will be writing another function Bull starts with. Here we'll be having string prefix node. Node is equal to root. That means we will be traversing from the root node. For character C prefix, if it is not containing or if doesn't contain the character, then we'll be returning false. And node is equal to node next of C. Then you will be returning true if this conditions are not, if this condition is not satisfied. Now wait a second, this should be at here. Now int count prefix suffix pairs. Here n is equal to words dot size, int count is equal to 0. For int I is equal to 0, I is less than n, I plus plus. And tree prefix tree, as I said, we will be initializing prefix string and suffix string. Now prefix tree dot insert words of I and string reverse word is equal to words of I. So here you will be reversing this words of I. Reverse word dot begin, comma, reverse word dot end. So suffix tree dot insert reverse word. Now after that, for int j is equal to 0, j is less than I, j plus plus. If words of j dot size is greater than words of I dot size, then we'll be not considering this. And then string prefix word is equal to words of j, and string reverse prefix word is equal to prefix word, and then we'll be reversing this reverse prefix word, reverse prefix word dot begin, comma, end. Now after reversing this, if prefix tree dot starts with, if it starts with the prefix word and suffix also, suffix tree also starts with reverse prefix word. So if it starts with reverse prefix word, so if it starts with reverse prefix word, then increment our count. After that, return our count. So this is how we solve this problem. So wait, node links, sorry, here I forgot to initialize the class node. Sorry. Here, so if you like my explanation, please like this video, share to your friends, and subscribe to my channel. Thank you.